So we're going to continue with our lesson on logarithms, okay? And we've talked about rules of logarithm, intro, and then properties. So in case this is your first time, I entreat you to check out the other videos, okay? So a quick recap: we talked about one property of logarithm, okay? Where we learned that log a, the logarithm of any number to the base of that same number is 1. Okay, so an example, let me give an example. Log of 5 to the base 5 is just 1. Just note that. And also the logarithm of 1 to any base is 0. So just note that. So you can have logarithm of, say, 1000. Okay, logarithm of 1 to the base, say, 1000 is still 0. Okay, just note this. You have to know this. Okay, so back to today's lesson. We're going to talk about change of base. We're going to talk about change of base. Now, this can also be numbered as the fourth rule. Okay, fourth rule of logarithm. So with change of base, we have something like if you have an expression like log of, say, x to the base a, it can be expressed in another form. Okay, it's the same as saying that log of x to the base a is just log, by introducing a new base. That's why we're saying change of base, from an old base to a new base. So let that new base be, say, b. Okay, so it then becomes log of x to the base b all over log of a to the base b. So I've introduced a new base. Okay, I'm going to prove it, but remember, we won't be quizzed on proving. Okay, so just note this. Okay, note this. So the number here, the number here becomes the number with the logarithm on the as the numerator, and then the denominator, we are seeing the base becoming the number at this point. Okay, so note this, but they must be in the same base. Okay, so let's prove. So let log of x to the base a be equal to another variable, say c. So therefore I can say that x is equal to a exponent c. Okay, a comes and pushes the c up. So this is the exponential form. Okay, so now introducing the new base. Let's introduce the new base. Introducing the new base b. We can say that, so I'll take logarithms of both sides. Okay, so log of x to the base b will then be equal to log of a exponent c to the base or to the base b. Okay, so we know from the third rule that when you have an exponent at the top of a logarithmic equation, it comes to the other side and multiplies. Okay, so we are saying that log of x to the base b will be equal to c times log of a to the base b. So we divide both sides by this expression, so therefore making c the subject. So c will then be equal to log of x to the base b divided by log of a to the base b. But what then is c? We said here that c is equal to log of x to the base a. So log of x to the base a will then be equal to log of x to the base b all over log of a to the base b. So we've proved that. So that's the concept of change of base. So you solve more examples so that you understand. Okay, don't get confused. Here we divided both sides by log of a to the base b, so this goes off, and the log of a to the base b comes to the other side. So that's the simplified form. So so don't get confused. So from this we can also derive another. So let's say this is the fourth rule. You can also derive another property. Let me say, okay, that's called the inverse. Okay, so we can say that log of say log of x to the base a will be equal to 1 over log of say log of this becomes the opposite. It becomes x log of a to the base x. Okay, it is the inverse form. How do we do that? Now let's assume that b is equal to x. Okay, so b is equal to x. So when I substitute that into equation 4, we have log ax will then be equal to log x over log xa. So this is just 1. Okay, so therefore log x to the base a is equal to 1 over log a to the base x. It doesn't. So this should be 5. So once I substitute that into equation 5, sorry, this is 4. Sorry. This is 4. This is 4. So this becomes our fit. It's just a derivation. Okay, now let's widen the scope of our understanding by solving more questions. Okay, so we have log 5 to the base 3, and we are saying that when we introduce a new base, say base 10, it's going to become log 5 to the base 10 all over log 3 to the base 10. So you can confirm this by using the calculator. Okay, so point this onto the calculator and you're going to get 0.69897. Then log 3 to the base 10 will give us 0.47712 and so on. So punching this, we get 1.46497, but we have to divide this. Okay, and when we divide it, we get back 1.46497. so the law is true. I mean, this is confirming that. And also with the inverse of a logarithm, when for example, let's use the same log 5 to the base 3, we can say that this is equal to 1 out of log 3 to the base 5. Okay, and we can confirm this using the calculator also. So when we punch this, we are going to get 0.6826. okay, and when we evaluate this, we are going to get 1.46497, which is the same as punching this onto the calculator. So this is also correct. Okay, so let's solve a question. Okay, so we have this question: log x squared plus 3 to the base 10 all over log x plus 1 to the base 10. Okay, is equal to 2. So we can use two approaches to arrive at the answer. So the first approach is to do the normal thing where we cross multiply. So log x squared plus 3 to the base 10 is equal to 2 times log x plus 1 to the base 10. So following the rules, it becomes log x plus 1 all squared to the base 10 x squared plus 3. Okay, and we know that when you are given a logarithm, say log b to the base a is equal to say log c to the base a, they are in the same basis. This will only be true if b is equal to c. So therefore we can say that x squared plus 3 is equal to x plus 1 all squared. So expand and then you solve. But then you're going to get your final answer is going to be x equal to 1. So try solving it and this will be your final answer. Okay, so this is the first approach, but we're going to use the approach involving change of base. So how do you do that? So this is the new base, so we're going to convert it into the old base. So with change of base, this becomes the number and this becomes the base. So log x squared plus 3 to the base 10 all over log x plus 1 to the base 10 will be equal to log x squared plus 3 to the base x plus 1. Okay, so therefore I can say that log x squared plus 3 to the base x plus 1 will be equal to 2. So this comes here and pushes the 2 up. Okay, so using the rules of logarithm, you can say that x squared plus 3 will then be equal to x plus 1, will then be equal to x plus 1 all squared, which is the same as the one, this is the same as the one we arrived here, the one that we got here. Yeah, that's it. So you can use change of base to get your answer. The answer should be x is equal to 1. Okay, so thank you.